HOSST is a graduate college that combines students from GEOMAR and Christian Albrechts Universität in Germany and Dalhousie University in Canada. These young researchers all work on different topics of the North Atlantic. Iceland is in the middle of the North Atlantic, and it's also the upcoming part of the Mid-Atlantic Ridge, so the seafloor ocean that comes up on top.
In the whole system of the North Atlantic, Iceland plays a special role.
It has volcanism, it has the glaciers. You can really look at all these different features, which you're not able to do, for example, in Germany.
To really be so close to it sort of helps you drill the message down that, okay, yeah, something like a glacier can actually really impact.
It is somehow more advanced because we are right there. Europe's largest glacier is melting. We took this boat around the icebergs, and they even told us there that this glacial lagoon was much smaller just 70 years ago. And that's also very interesting for me because I studied the influence of melting ice sheets on the ocean circulation, and I haven't seen this before.
I'm working on the Cape Verdes and their evolution. Of course, it's a different setting, a different environment because it's a hotspot. And here on Iceland, we have a rifting zone that interacts with the hotspot. But in both places, we see new land growing. And we can actually see on Iceland how the rift and the hotspot interact with each other. And we can see really where are the older parts, where are the younger parts, and where it is actually right now happening.
Put your hand in the crack, it's warm.
So it's still active. We can still see the steam and hydrothermal activity there.
It was really great to see it here on land, how it's working and how all the elements came to the surface and are precipitating out. So what we can normally see in an outcrop, we can see live. Like here, for example, you can see calcium carbonate. It's directly precipitated at the surface.
What it feels on if you touch something, if you feel it, if you smell it, I think that is really important.
I do numerical modeling, and the input parameter for my models is, for example, the structure of the magmatic chamber. And here I have had the chance to get a closer look on that. Really interesting was the visiting of the hydrothermal power plant, because they get a sustainable heat out of the magma chamber.
If you look at the landscape, you can see several more or less flat bits going up like a stairs. The upper ones are the really old ones. Sometimes I can lose track of other things going on and just walk by a hill and think, oh, this is glacial and this is going on and that's going on and the river is doing this. And then someone else comes along and says, oh, but look, there's a cinder cone and there's a volcano in the back. And then all of a sudden it's opening you up. And I think that's really important for me in my research as well, not narrowing down the whole time to, okay, I'm doing barium isotopes, and that's just like a tiny, tiny part of what the whole world and the Earth system is about.
The diversity is so low in Iceland, so you would say that it's really boring for biologists and there is nothing to study here. But actually it's quite the opposite. Here we have around 300 fish species. We see the same structures, but everyone finds different topics.
So it intruded when it was still submarine?
The best moment for me was when the chemical student said, well, I didn't know how interesting geology is, and maybe I should switch topics. This was the moment that I thought, well, this is worthwhile, showing someone who is doing something completely different, showing this nice geology here and get him interested and excited.
Everyone has a small piece he can add to the big puzzle, kind of, to the North Atlantic.
I think that was really important for us, for our training, to become advocates of the ocean, which is one of the main aims for HOSST.